Alright guys, this is a short video just about what a net is and how to find 2D surface area. So a net is just a 2D representation of the surfaces of one of the 3D polyhedron that we're dealing with. So here's an example of a cube where we cut it up and we say, okay, well let's say we cut down each of these sides, right, to open it up, right? So we cut down each of those sides. Well, we have to cut the top off too. So what we did is we said, okay, well, let's also cut along 3 of the sides of the top. So this flap can open up this way. So kind of it's like vertical now. And then we cut down each of the sides like here, 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 and here. And so we opened those 3 sides down. And then this one side had 2 because it had the top flap. And so we flapped this whole side down. And so we got the 2 here. So we cut this imaginary like dimensional scissors down each of the seams that we select, and then we can open up the 3D figure so that the 2D surfaces splay out into this 2D representation. All right, so here's a cool question. So which of these nets, so remember a net is that 2D representation of all the surfaces, could be folded up to make a pyramid, right? So if we fold these 2 up, okay, so that's going to be we have this with one side here correct. We have one side here correct, but look at this though. This one would hinge on top of this one, right? No matter how you wedge it up, these 2 would end up overlapping because once you put these 2 upright, then you have to hinge one over this way and it just covers up that same face. That was from a top-down view, by the way. Okay, let's do this too. Let's flap both of these down. So we have in this triangle, we put one here, okay, and we put one here standing up. But now we have 2 flaps that are both coming this direction. So we have 2 flaps both coming off to this side, so we cover up this twice. So both of these would cover up the same surface. So none of these are completing the pyramid yet, okay? All right, so this next one, we go, okay, well, what will we start with, right? Well, let's start by putting these in, okay? So bird's eye view, we have this. We connect this side and this side, okay? And what would that do? Then this one would hinge over this way, so it would go here, okay? So maybe let's color code that. So this green one would flap here to this green one, but then shoot dang, this one goes in the same direction, so we would have another one unflap to right here, so this pink one would overlap with this pink one right here. Oh, dang, so that one wouldn't work. Let's look at the last one here. So we start with this, and we flap up the blue here, and we go, okay, so we got that blue. And then connected, this edge would now be like, if I highlight it, this pink edge would now be right here. And so we'd have a triangle there. Well, this seam would meet this seam, and so we get this pink triangle like this, okay? That's good. So far, so good. And then along this orange seam, which is right here, we go, oh, and now this edge would meet this edge, and we'd flap it down, and we get this orange triangle. We go here. Oh, so far, so good. All right, and then let's try if the next one works too. Let's go with purple, green. Okay, and so the last one, we'd have this green edge here is now this green edge here, and we'd say we'd flap it again, and we go, oh, you know what? It landed perfectly. So this is the only one that could be folded up to make a triangle. And that'd be a cool thing to just try and cut out in paper. It would take you maybe 3 minutes to 5 minutes. It'd be a cool like actually unfolding and putting it back together to see how it worked. All right. So nets are how we're going to start by looking at surface area, right? So here is a triangular pyramid. And if we just cut down the 3 edges here and flap the 3 triangular lateral faces down, this is what we end up getting. Here's the base, and then we have these 3 lateral faces that opened up like a flower. Okay, and now we could easily find the surface area of this figure. Okay, so draw a net for a cube different. So last time we opened it up in a very specific way, but let's say we take that cube and we open it up differently this time. Okay, so what should we cut first? Well, let's just cut off one flap, okay? Let's say we cut that flap and put it down. All right, so now we have that flap out like this. Okay, well then what could we do? Well, let's also cut along this edge and this edge, and then flap the whole box down. Okay, so now we've got we've got 2 box edges like this. And then we've got still how many left? We've got 1, 2, 3, and the top 4. So we still got these 4 faces left. Well, let's cut again. Let's cut again right here and right here. And so we could open this edge up even 1 more. So we got 4. And then why not even cut it again? Let's cut the last edge here, this last edge. Oh no, not that edge, because then we'd be cutting the sides off. Let's instead, let's see. So once we've opened it up that far, so we've got the orange face. Oh, we just have the last 3 faces are laid out. So the last 3, which would be the 3 that go around like this one, and the back one. So these 3 faces would be left right here. So that's one. Another one is basically any representation similar to that. So I could have drawn one like, as long as I have these 4 faces like this, I could have the 2 lateral faces anywhere on these 4 and anywhere on these 4. So I could have one be like this and one be over here. That's another net for it. There's even more like crazy ones that are harder to imagine. Let's see, could we do something like this? And then, let's see, go this way. So those are the 2 bases when we fold them up. Okay, so where would the next one go? Is there any way to go off of this side? So when we fold that up and fold that up. Oh man, this is so cool. I love this. What a good brain exercise. Could we, okay. So if we fold that up, those would be, so we need a face here. Yeah, so we could put that face here, I think. And then maybe could we put a face here? Would that work out? So we'd put, this would be the bottom, okay? This would be like the right side, or the right face. This would be the front, okay, as they go up. So yeah, this would be the left. This is looking good so far. And then this would be the back face, right? So as we fold up, it would swing, and it would be the one like in the rear there. And then that would make this one the top. Hey, that one worked too. Ah, very cool. Man, what a good brain exercise. So there's 3 different versions of a net for number 1. Okay, so for each solid, draw a net and find the surface area. So here's where it actually starts coming in handy, okay? So let's cut this open. I'm going to just lay it like this. So we'll say we have, this is the base sticking out of the bottom, kind of. I'm not going to draw it right there yet. And then this will be the base sticking out of the back. Okay, that's the idea. And then we'll unroll this 1, 2, 3, 4, like the around this face, this face, this face, and that face as the lateral faces, okay? All right, so let's open them up. All right, so what we have is 7 by 6, a 4 by 6. So this one was 7 tall, so when we unwrap it, it's 7 that way. This is always going to be 6 for all of these. And then this next face was, so this is, if I labeled them, like maybe this is right. Whoops, that's a right. This is a bottom. This is a left. And this is a top. So what I'm getting here is this is my left. This is my bottom. This is my right. And this is my top when I laid it out. And there's absolutely more than one correct net here. So this was 7 by 6. This is 4 by 6. And then out of these, we have the base, the back and the front sticking out. So let's say this is like the front, and ooh, I don't know. Let's call the back a W for no reason. So that face. So the front could be sticking out at any of these, but the key is it's 4 by 7. And then on the back, when it flaps down, it's a 4 by 7. Here we go. And then we just find the surface area by finding the surface area of, or the area of each one of these and writing it in. So I'll do it in blue. So this would be 28 and 28. This would be 42 and 42. And this would be 24. And this is 24. And so then when we add those all up, I'm just drawing this separate. When we add those all up, we just get that the surface area is 2 24s plus 2 42s plus 2 28s. So that's 48 plus 84 plus 56, or what, 120, 132 plus 56, so 188. All right, the next one, Again, I'm going to stick with like unwrapping the lateral faces and leaving the bases sticking out. So I'm going to unwrap and say, turning it kind of sideways. So I go, here's the 9 side, and then we're going to unwrap the 9, okay? And then on one side we have a 17, right? So we have a 17 by 9, okay? That's the top. And then we also have a 9 by 8. Right, those are connected on the edge of the 9. And then we have this other back side, which was 9 by, oh, we have to figure it out. So this is a right angle, it shows you in the picture, and this is a 17, that's an 8, 15, 17 Pythagorean triple, or you just use the Pythagorean theorem. So the last side there is 9 by 15 on the rear. And then this triangle sticking out, I need to make sure it looks like a right triangle. So this is right triangle where 17 is the hypotenuse. There's a right angle, 8, oh wait, I got to match. That's not the right order. The 15 has to match this 15 that folds up. And then the 8 would match over here for the 8 flap that would come up. And then I would do the same thing on the bottom. So then I have the same right triangle here of 8 and 15. And then we just need to find the area of all these. So 9 times 15, that's 90 and 45, 135. 9 and 8, 72, 9, 17, that's 90 and 63, so 153. And then up here, that's 1/2 base times height, so 1/2 8 times 15, or in other words, 4 times 15. Okay, and then same thing down here because it's the same base. So the surface area of this one is 2 of the 60s, plus a 135, plus a 153, plus a 72. So we get 120. Plus, and then these two together, that's 288 plus 72. So we get 120 plus, and these seem to go together well. So a 2 makes it 290, and then so that'd be 360. So that'd be the surface area is 480. Okay, now let's do a different color here for the next one. So this one, I often open up pyramids like a flower. So you just say, okay, so here's the 4 by 4 base, right? And then each of these triangles opens up like this from that base. And those are all 6 height. And so each of the triangles is area 1/2 base times height, or 1/2 base of 4 times height of 6, or 1/2 of 24 is 12. So each of these is 12, 12, 12, 12, and 4 times 4 is 16 in the middle. So the surface area is the base of 16 plus those 4 lateral faces that each have a 12. And so that's 16 plus 48, or in other words, 58, 64. Whoa, 64. Okay, we'll just do a couple more problems, and that's it for this video. All right, so let's do, I think these are the last. Oh no, I did some harder ones down there, but those we're not doing a net for the last ones. Okay, which cannot be folded up to make a pyramid? Well, we flap these up, of course it can be a pyramid. That's an easy one. Okay, well this one, let's draw it. So we could flap up these 2 blues, and that would be here and here. That's good, okay. And then this one along the orange edge here would be right here, and it would flap over. So yeah, that one would work. Okay, let's try the next one. Well, let's say this is the bottom. Okay, well then we go, okay, if that's the bottom, then we could flap up this flap and that flap, right? So these 2 are covered. And then this orange edge would now be right here, and so it would flap over. Good, that one will work. Let's try the last one here. Let's say this is the base. So if that's the base, then we get these 2 faces cover here and here. Good. And so, because this one went up, and now we have this edge would be right here, and it would be correct. Wait, did I make a mistake on one of the other ones? It says which one can't. So it's got to be one of these 2, right? So let's see. Yeah, but that one checks out. That one can. And that one can. What? Because, I mean, these are the exact same thing. So if one can, the other one can. this one for some reason. Oh, I got my edges backwards on that one. Look at this, what I did. So yeah, let's look at this. Okay. So it was C. The reason C can't go on is when you fold it, I got my edges mixed up. So when you fold these two triangles together, this orange edge isn't where I said it would be. Actually, the orange edge, when you flap these up, the orange edge meets this green edge here, and then this triangle would overlap. So we'd have the green edge would be right here, and the orange edge would be right here, and then we'd be flapping over this pink triangle onto here, which already has a face. So it's this one that can't be folded into a triangle. Yeah, so let's see. Yeah, no matter how you slice, I just tried it a different way mentally. So C is the one that can't. Oh, see how tricky these are? These are fun. Okay, for each solid, draw a net. So I'll do it vertically this time. So I'll consider this one as my base sticking out, and I'll do the lateral faces. So we have the 4 across, and so we have a 3 and a 3, and another 3 and a 3, and another 3 and a 3, and another 3 and a 3. So all of these are 4. So I unwrapped the sides of this, and then out of any one of these edges, we have the 3 by 3 square sticking out. And so the areas of all these are 9, 9, 12, 12, 12, 12. So the surface area here is just 2 9s plus 4 12s, or 18 plus 48, which is 66. All right, let's look at the next one. So again, I'm going to just choose kind of arbitrarily. I'm going to do the 2 by 5 is the base. And so 6 is the distance between those bases. So when I draw this, I'm going to say I have this rectangle that's 6 across, okay? And then the first edge I'm going to do is the 5, and then the next will be the 2, and the next will be a 5, next will be a 2. So we have a 5 by 6 rectangle, that's this front one, okay? And then we have a 2 by 6 rectangle, that's the one next to it. Then a 5 by 6 rectangle, and then a 2 by 6 rectangle. So these are all the wrappings, and then I'm going to put the pink ones sticking out. So the pink ones sticking out are the 5 by 2s, and so that would be 2, right? And these two edges, when we fold it up, would meet because they're both 2, so it all checks out. Okay, and then we have the same thing sticking out the other side too. We have the 2 by 5 there also. So if we figure out the areas here, we get a 10 and a 10 and a 30 and a 30 and a 12 and a 12. So the surface area is 2 10s plus 2 12s plus 2 30s. So that's 20, 24, and 60. Or in other words, 44 and 60 is surface area 104. All right, now let's do the last one here. So again, I always open these up like a flower. So we have a 4 by 4 opening up to this, where each one has a height of 6. Oh, 5. And so then you just do the separate areas. So we have 16 in the middle. The triangle is going to be 1/2 times 4 times 5 because of that right angle. So we have 1/2 times 20. So each of these is going to be area 10. Okay, so we have surface area is 16 plus 4 10s. 16 plus 40 is 56. All right, let's do one more here. So one more group, I mean. All right, so let's open up these lateral faces. Again, I'm going to leave the bases of this prism here as sticking out from the lateral faces. So if I open up the lateral faces, the distance between the bases is 7. And so one edge is 4, and then the other two are 5 and 5. And then sticking out of any one of these bases, let's just stick it out of the 4, is the 5 5 isosceles and the 5 5 isosceles. Right, so there's one possible net for this, and then we just find the area of this. So that's 28, 35, 35, and then we have that classic isosceles triangle, which comes up so much. So if we have a 5, 5, and a 4, we cut it in half, and because it's isosceles, we get that symmetry. So these two triangles are the same, so right angle. And so now we just need to find the height of this. We can use Pythagorean theorem to say 2 squared plus h squared is 5 squared. So 4 plus h squared is 25. H squared is 21. So h is square root of 21. So up here, we have a 4 times a height of square root of 21. So the area of those triangles is 1/2 base times height, or 2 root 21. Okay, so each of these areas is 2 root 21. So the total surface area then is, I can't zoom out, there we go. Surface area is 2 of the 2 root 21s for the two bases, plus a 28, plus 2 35s. And so we get 4 root 21, plus 28, plus 70. In other words, 4 root 21, plus 98. Okay? So let's do those last two problems then. Shoop. So this one, again, I'm going to choose the odd base shape as sticking out the side. So these are going to be my two bases of the net. So I'm going to draw these lateral faces like this. Okay, so we have the distance between those two bases is 8. And then one edge of a rectangle is, I don't know, let's start with, we have to find this last one. Let's call this x for now because we don't know. All right, so we'll call this some x length. And then the next one, going in order around the shape, would be an 8. And then it would be a 6. And then it would be a 6. And so let's have it sticking out of the 8. And so out of the 8, we have the slanty part is going to the x, right? Those two are going to match up, and the straight part is the 6. And so it would be 6, 6, and this is an x length. And then same thing here. We have, this is a 6, 6, x, and this is 8, 8, x, 6, 8, 8, 8. So that would be a net for that one. So we need to find that x length, and we need to find the area of a trapezoid, right? Because otherwise, the rest of this is just 64 area. This is 48 area. This is 48 area. So we got two questions here. What's the length, that unknown length of that slant? And what's the area of a trapezoid? Well, let's do the area of the trapezoid first, because that's directly just area equals 1/2 base 1 plus base 2 times the height. Well, in this, we have the base 1, we have the base 2, and we have the height. So that's 1/2 base 1 plus base 2 times the height, or 1/2 14 times 6, or 7 times 6, or 42. So we know the area of these two is 42. Now we just need to find that slanty height to find that last unknown area on top. Well, let's draw it right here. We have a trapezoid, and if we lop the side off because of these right angles, we get a rectangle, which is 6 by, not even a rectangle, square. But we know the total length here was 8. So that means this unknown length is 2. And now we know this is 6 because it was a square. So we can just use Pythagorean theorem there and go 2 squared plus 6 squared equals that unknown x squared. So 4 plus 36 is x squared. So x is equal to square root of 40, or x equals root 4 root 10, or 2 root 10. Okay, so here's a 2 root 10 and a 2 root 10. Whoops. And so multiplying that by 8, the area of this is 16 root 10. And then we just add those up for the whole surface area. So the surface area is, we get 2 of those bases, 42, plus 2 48s, plus a 64, plus a 16 root 10. And so that's 84 plus 96 plus 64 plus 16 root 10. Just combining on the left here, this is 160. Whoa. This is 160 and 84, so that's 244. So we get 244 plus 16 root 10 as the surface area. And shoop. Last one, the net of this. Again, I'm going to choose the irregular bases as sticking out from all the lateral faces. So my net is going to be like this, where the distance between my bases is the across 5. I'm going to choose any one to start with. I'm going to start with the 6 side. Okay, so from the 6, then in order going around is then a 3. Okay, and then another 3. And then, oh, look at that, the same slanted unknown side. And then let's do the big 6 is the flat part. And so the 3 and the 3 are that irregular. Oh, this is like the exact same problem as the last one. So we get, again, a trapezoid that's part square, part unknown length. And so we just do the same thing up here. We go, okay, well, if this trapezoid was 3 by, 3 with, chop it off, a square here. This is 3 and a total of 6. So that means this was 3 and this is 3. Oh, well, that's a 45, 45, 90 triangle. So that unknown hypotenuse there is a 3 root 2. So that's a 3 root 2, which means down here we had a 3 root 2 for the unknown. Well, now we can find the area of all of these. So this is 5 times 6, 5 times 3, 5 times 3, 5 times 3 root 2. And then we have to find the area of that trapezoid. So the area will be 1/2. You add the two bases and you multiply times the height. And so in that trapezoid, the bases are a 3 and a 6, and the height is a 3. So that's 1/2 9 times 3, or 1/2 of 27, or 27 halves. All right, so finally the surface area is, we have, I'll start with the bases. We have 2 of the 27 over 2s, plus 2 of the 15s, plus a 30, plus a 15 root 2. So that's equal to 27 plus 30 plus 30 plus 15 root 2. So that's what, 60 and 27. So that's 87 plus 15 root 2. And again, you could always smash that into a calculator if you want. All right, you guys, that was a cool video, just me walking through creating some nets.